Alright, so I'm going to do a walkthrough of this assignment because I found that doing this one in the summer without much help or guidance to the student, the time constraints just doesn't really work. So I feel that it's kind of necessary to give a bit more help on this one than I normally would. So the entire overall goal of this one is to investigate something called Benford's Law. Feel free to look it up, but what we're going to do is we're going to build up through a lot of small programs, a lot of methods to do this. So the idea here is that we move through all these small little exercises and make one really big exercise that relies off of everything else. So let's get started by just kind of going through. And this will help you understand the flow of this. So the first thing is to count digits. Now it says review even though you've not really hit it before, but that's because I wrote this for students taking CS2. Their second class. So count digits. We'll start out with something we've done in class, which we haven't here because, again, write a function called countDigits that takes in an int num and will return the number of digits in sum. So, for example, if we give it 1, it's going to give us, we will get 1 back if we feed in 0 through 9, 2 if we give 10 through 99, 3 for the numbers 100 to 99. That means basically, let's go ahead and start our program over here. We're going to call this program looking out, right? Because we only just need one big program for this one. But the program's going to be made of lots of small ones. Now, rather than going straight into writing PSVM, public static void main, instead I'm going to go ahead and write my first function. Public static. Okay? And now remember, functions, what we need to do is that they start out with public and static. We don't know what that means yet. Then we have whatever the type is of what we're giving back. In this case, it's the number of digits. That's an integer. So we're going to give back int. Finally, we give the name, which we're going to call this countDigits. And then we have this part in the parentheses. These are the arguments you take in a function. So think of this as the output, and what goes inside the parentheses here are the input. The parentheses are pretty much in programming used only for our functions and function calls, to invoke a function or to say what the parameters are. In other words, you can think of these as creating new verbs in our programming language, and these only ever get associated with verbs. So int num. This says if you give me a number that of the top, and that number, we could put whatever gobbledygook there as the variable name, but instead we're just going to put something sensible like num for number. It says if you give me an integer, I'm going to give you an integer back. Okay, and the idea here is, before I go into the idea here, there's one more thing that I find very important. Notice that basically that IntelliJ is constantly trying to compile, is constantly trying to see, hey, is your code going to work? So I don't like ever having errors in my code. I can leave, I like to work and jump around on multiple things. So if I leave errors lying around like that, that's going to cause me pain in the future. So instead, I'm just going to put in an answer, even if it's incorrect. How many digits does this number have? It has -1 digits. That's incorrect, obviously. No number can have a negative number of digits, right? It's obviously incorrect, though, so obviously it needs to be replaced with the correct answer. But the reason I do this is so that now this technically is working code. It doesn't work with our desire, with what we want it to do. No, it's just working code. Okay. Next we have public. Let's go ahead and write our public static void main, and this is how we'll basically test it. We'll basically test it by saying, hey, here's 89. And let's go ahead and I'm going to cut this, Control X, or Command X on a Max. So, countDigits. There we go. Now we hit the run, and it's going to say, oh, 89, that has -1 digits in it. Obviously, again, incorrect, but this is kind of the flow that we'll use for testing. So there it goes. So what we would really like to see for this is 2. It has 2 digits, an 8 in the tens place and a 9 in ones place, right? If I were to put in 189, it should say I have 3 digits. This is a 4-digit number, right? This is just telling me how many digits the number has, right? And again, this kind of little gray text that's not monospaced, so it doesn't line up exactly with everything. That's just kind of reminding me, oh, what is the variable name of what we put in here? It's num. If I change this to number, that's going to change the number. Basically, if I'm working somewhere else, I'm like, right, what's supposed to go in there? Oh, the number. It's just a reminder. It's picking that up from there. So, okay. So that's enough with those kind of formalities, I think. Let's go ahead and solve this problem. So there's a couple different ways we can solve this one. The first and kind of most intuitive way for a lot of students, but the way I definitely don't want you to solve this, is that we say, oh, I can't tell how long a number is, but I know how long a string is, so here's what I'm going to do. I'm going to go ahead and I'm going to say, let's go ahead and say string num is equal to number. Let's see. Let's go ahead and switch this back because I had num. And then we're going to go ahead and say num text. We're going to just turn this into a bunch of text. Can't do that. Well, you can actually turn anything into a string by, just concatenating it with a string. That's kind of a nice little trick in Java. In Python, you do stuff like str in parentheses, but in Java, you can turn anything into a string by concatenating it with a string like that. It's an easy way to do that. The point is, we turn it into a string. Again, this is the way I don't want you to do it, but it's kind of intuitive. And now, since it's text, you can tell how long that text is. So we would just simply say numText.length. And there we go. And it says, 4? Well, that's 1 digit long. 5, so 5, 6, 7. This is 4 digits. Now, I said I don't want you to do it this way. What if you turned it in? What if you never saw this video and turned it in like doing that? Would I care? I'd mention, hey, you should probably learn how to do it this other way. But no, you'd get it right because it works. It's just, it's a less efficient process. Yep, 4. That's what I'm looking for. 4 there. Okay. This conversion process of turning something into text is a bit more expensive on a low-level kind of level of detail than what we're going to do next, which is we are going to say string, which we're going to use math here. Okay, we're going to say num digits, and you'll have to excuse me, I got to remember to put int. I've been working in Python for a while and haven't had to do that. So num digits is equal to 0. So we're going to create an accumulator here. This is going to be our answer. How many digits does it have? It has num digits. And return that digit. So we're going to figure that. So we're going to figure out the number of digits. We're going to store it in there, and we're going to give it back in this variable. So, what tools will I use for this? The tools I'm going to use here are the divide symbol and the modulo symbol. Okay. Why am I using these symbols? Specifically, I'm going to be dividing by 10. And modulo by 10. So a fun thing happens in Java because of the way in most programming languages, because of the way the way division works. If you divide by 10, it's integer division, so there's no remainder. So dividing by 10 is effectively the same as chopping off a digit. So we can simply divide by 10, and if we divide 987 by 10, we'd end up with 98. And if we divide by that by 10, we'd end up with 9. And if we divide by that by 10, we'd end up with 0. Remember, this is doing integer division, which means that when you divide, you basically ignore the decimal places. Kind of do 4th grade arithmetic where you're just caring about the quotient and the remainder. Here, we're just caring about the quotient, and then this would get us the remainder. So this essentially, dividing by 10 essentially throws away the last digit. Moduloing by 10 throws away everything but the last digit. Or another way to look at it is that it simply retrieves the last digit. You don't have to throw everything away. Okay, this will be relevant for the next problems. This one over here is what we need right now. Because what we're going to do is we're just simply going to take this number and we're going to continuously divide it by 10. And the number of times we can divide it by 10, that's the number of digits we have. Think about it for a second. You know, work through it in your head and you're like, oh, okay, yeah, that's the way it works. So while num is greater than while num is greater than 0, because we want to stop when we're at 0. Greater than or equal to would mean that once we hit 0, we'd keep going and kind of crash into an infinite loop. So while the number is greater than 0, it's kind of giving me a warning because it's saying, hey, number never changes. It's always going to keep going. Oh, and yes, it's an empty body too. So let's go ahead and see here. Num. So first what we're going to do is we're going to do num divide by 10. That would get us this would throw away the last digit of number. And we're going to take that and we're going to store that in number. So, right, we're going to take what's on the right and store it on the left. So basically this says throw away the last digit, right? This gives us, so 987, this would give us 98 and store it in number, overwriting the previous result. So we've done that once. And so now what we want to do is we want to say numDigits plus plus, or numDigits is equal to, which is a shorthand way of saying numDigits is equal to the number of digits we have had so far, plus 1. So this kind of format is definitely the thing you want to master before moving on to the next thing, which is that, oh, right, okay, I can update variables like this. I can update variables like this. I can take what's on the right and I can store it on the left, and even though that's an equal sign there, it's not really the equal sign. Okay? It's not really the equal sign, it's an assignment operator, right? When you see an equal sign in computer science, you want to think more like this. Arrow, right? Which would be great, except that arrow is made up of a less than sign and a minus sign, which that's like less than negative, so we can't use that, and then this kind of gets ridiculous in number of keystrokes. In some programming languages, we use something called the walrus operator instead. If you turn it on its sides, here's the walrus's eyes, and here's his tusks, right? Hence, walrus operator. But equal sign works. Once you kind of expand your meaning of it to mean, oh, it's an assignment, and we set what's on the left equal to what's on the right. That kind of works there. All right, so I'm going to be splitting this up into multiple videos. Okay, see you on the next one.